Hi. So yeah, my name is Alex Eagle. I work on the Angular team. I've worked there for about 4 years. I'm the lead of what we call the Angular tooling team. So we've split the Angular up into one group works on the framework itself. One group actually supports TypeScript internally at Google. One group works on our material design components. And then the tooling team owns things like Angular's CLI, the command line interface. This is the tool that most Angular developers out in the wild use to both create and then build and serve their Angular apps. And our team also owns the Google internal toolchain for building Angular apps. And my mission in life for the last couple of years has been to try to converge these two things. And obviously, Bazel is right at the center of that. So prior to working on Angular, I actually worked on Google's continuous build and testing systems and was one of the first people, together with Peter Epstein, we wrote the first build event protocol in Bazel. So I've had some history with the project, too. And so I'm really glad to be able to do Bazel stuff and Angular stuff at the same time. So I have imposter syndrome. Hopefully a lot of you do too. And so I'm not sure why I belong at this conference. Like web development, it doesn't even seem very hard, right? It's true that you can learn HTML in 5 minutes. This is a YouTube video. I won't play it because I don't have the extra 5 minutes. But you could learn HTML in this talk. And then after you've learned HTML, you get WinFTP. I don't know how many of you did this. I did this when I started doing development a long time ago. So you just edit the files, and then the website is updated. And it sounds like a joke, but front-end developers are more junior on average than other developers. They're paid less, according to Stack Overflow. So you might be forgiven for thinking, well, web development sounds kind of easy. The more junior people work on it. I don't need to work on this as a more senior developer. So it just looks easy. And of course, that's not true. So then when you peel back the covers a little bit, I love this. So I read the book on the left. I have the book on the right. I would never bother reading that. So it makes you wonder how many, the bad parts seem like it's 80% of JavaScript. And that's the perception, for sure. So JavaScript has a lot of super weird semantics, and you can go through a whole list of them. This is WTF.js. Seemed like a nice synopsis of some of them. For example, not a number is not a number. They're not equal. And of course, triple equals are different from double equals in JavaScript in a lot of tricky cases. So all this stuff, it just sounds crazy. And then you look at the fragmentation of the front-end ecosystem. So web developers, you learn HTML, CSS, JavaScript. You're on your way. But then there's this much longer path. It doesn't fit on one slide. So this is the second half of it. And Angular is just one box in here. And Angular is, by itself, quite a large thing to learn. So I think nobody learns all of the things on this chart. So web development is this big, crazy world. It also has some questionable engineering practices. So there was the left pad disaster of 2017. Left pad is literally, this is the file. OK, this is the code. It's a little utility function that takes a string and gives you back something of a fixed width by padding some things on the left side. This is how you'd use it. You would require left pad. The require here is the problem, because you're not going to copy this code into your project. You're going to have it be an external dependency just to get this function. And then what happened was somebody unpublished leftpad from NPM, which is the package repository that everybody uses for both front-end and back-end JavaScript development. And it made it was a news story of the day, because basically nobody's JavaScript builds would work, because it's a transitive dependency. It's not that everybody was using this little library function, but it was depended on by enough of the tooling that everybody uses. So now it just looks unappealing, and now you just want to turn your heads and not look at what the front-end developers are doing on your team. I should ask, how many people do web development here? OK, that's what I was hoping. So for most of you, this is you don't know any better. So what I'm saying sounds true. So let me run through the ways in which it's actually hard. So there are a lot of limitations because we're targeting browsers. We're targeting a lot of different runtimes, actually. So browsers can natively load JavaScript modules, which is to say individual files, but not that many of them before it becomes a performance problem. And even before browsers had native support for this, there are a lot of client-side libraries like System.js that can load JavaScript dynamically. But again, you can't ship thousands of files to the browser, which means you could develop your whole app as one JavaScript file. A lot of people do that. And then you break it up into a few files, and you get to a point where it doesn't perform. So now you need a build system in order to bundle together all of your sources to be in one script. Now, what users actually want on the web is they don't want to download all that JavaScript at the beginning. They want to download it as they navigate the application. And so you need a build system again, because what you want to do is take that big bundle, split it into chunks, and then you want to be really sophisticated. You want to avoid downloading code that you don't need, but you also don't want to download code twice. And so finding an optimal partitioning of the code is a tricky problem. This is fake. But I'm just trying to demonstrate here that like what web developers are trying to do is actually pretty novel, which is like I want my application to just pop up. I never downloaded anything. I want it to be super fast. But then as I start navigating through it, it should feel like a real desktop application. So it's like a legitimately hard problem. I don't know how many of you did like Java back when OSGI was trying to do like dynamic shipping modules, like bringing up new jars in the class loader. It never seemed to work very well in Java. I know at Google we just ship 3 GB binaries always to our servers because we can. So users are on slow connections. We're trying to target low-end devices in emerging markets like India. So we need to be able to make our binaries really small. So we run pretty sophisticated minifiers. The closure compiler, which is the one we use at Google, is very sophisticated and can rename properties and then like update all the references. And this can interact with your code splitter because you have to rename a property the same way in the code that you load at the beginning and that you do as the user starts to navigate. You probably want type safety. Last year at BazelCon, I talked about TypeScript, so I won't talk about it much today. But it gives you the type safety that you would expect if you came from a language that has that. Obviously helps you find bugs and helps you write tooling, and it makes your editor just amazing because it always knows what you're doing. So this means now we need the build system to do another job, which is to run the TypeScript compiler. Same thing happens for CSS. CSS is pretty verbose. It's not very ergonomic to write. It tends to be very repetitive. So developers like to use a preprocessor like Sass. So the build system needs to run that to derive CSS files. Angular itself has a compiler. So we have this inside of your HTML. You can write expressions that are evaluated to do data binding and event handling and make your page live. So the build system needs to run that compiler to produce this really fancy form of JavaScript that the Angular compiler produces. So those are the easy things that most web developers know how to do today, I think, and are using tooling to do those things. But it's getting more and more challenging because we're pushing the limits of what we can do on the web, and the capabilities of browsers are increasing a lot. So here's some new things that are coming. So custom elements is a way to have a tag in HTML that you can teach the browser like what to do. And you just like this tag would come along with a small bit of custom JavaScript. That custom JavaScript, in order to interact with the browser, really needs to be using the ES 2015 syntax. I'm not going to go into the difference, but basically in JavaScript you now have a class keyword that we didn't used to have, and custom elements relies on that. So the build system, if you want to use these custom elements, you first of all need to take the code that backs this date picker and bundle it into a separate JavaScript bundle from the rest of your application. And it should use this different syntax. And so now you might have 2 different flavors of output from your build. UIs can be multi-threaded. I remember trying to figure out swing worker a long time ago in Java. Most web developers are not doing multi-threaded UIs today, but they certainly could be. And there's a lot of places where you have like an expensive service call, or you have like image manipulation. There's a lot of use cases where more threads are helpful. And of course, all of our devices are becoming multi-core. JavaScript by default, as probably some of you know, is single-threaded. It's horrifying. So browsers have this API where you say a new worker and you hand it a JavaScript URI, and it's going to go fetch that. So in order for that to work at runtime, your build system again needs to figure out, OK, which of the API calls that I'm making can be on a separate thread, whichever way the developer expresses that intent. And then that needs to get packaged up into a separate script and be available at runtime. Offline support and push notifications. This is all sort of bundled under the progressive web application umbrella, which the Google Chrome team is doing a good job of evangelizing. So a service worker is this thing that it runs in the browser even if your page isn't there. And it can intercept network requests, which means that it can make your page be offline. So if you want to have offline support, it can also notify the user about something that happened in your application, even if they don't have your web page loaded in the browser at the time. So again, the build system is involved. We need to create a separate JS bundle for this, and it also requires this descriptor that tells the service worker what URIs to intercept, and also you can ship some resources into the service worker. And an example of this of one of those is an application shell. So if you install a service worker, you now have a little daemon running on the person's machine, and so you can store things there even when they're offline. And so one of the things you store is what your UI will look like without the actual content in it. So just like the nav and the Chrome around the app. So if you go back to this site, that immediately shows up. And Angular.io, if you're curious how this looks, is actually using most of these techniques. So if you look at Angular.io on your phone and then you're offline in the subway, like you can still navigate the docs. It's pretty cool, but yeah, build system required. In particular, what the build system has to do here is like there'll be a section in your HTML where you just say loading because the JavaScript is supposed to take over and render your page. And so what you need to do in the build system is actually boot up the web framework, whatever it is, do that initial rendering, dump out the HTML and CSS that it created, and then replace that into the index HTML that you end up shipping in your app. So that's pretty complicated. Now you have to run a web framework inside of your build system. And then, of course, the full stack story is a place where Bazel is super useful. Most web apps, as far as I can tell from talking to some of our users, they just assume that when they make an API call, the JSON that comes back, they can just dot off of it with the following properties, and it's all hard-coded, which makes it really hard to change that API. At Google, we're obsessed with changing things. So we make a lot of use of the fact that if you change a protocol buffer, you find out that some front-end code needs to change along with it. You find that out very quickly. So it allows us to, and we can also do this sort of integration testing so that we can bring up the web app with its server and see that the two things are able to communicate. So now we want the build system to help us with the front end and the back end sharing the type information. So I think there are more of these, but that's enough time for that. So web development is hard. We have to run all of these things in the build system. And it's getting harder. So what do people do? The tools today are solving a lot of these problems, but I think it's not layered correctly. So what happens is users will solve that first problem I mentioned, where they have a bunch of JavaScript files, and it's too slow to run it in the browser. And so somebody says, hey, your website would be faster if you ran this tool on your website, using very vague terms like that. So Browserify, Webpack, and Rollup are the three most popular tools that do this. It could be just squashing all your JavaScript together, but they may actually have a harder job if you're using module syntax inside of the JavaScript files. Then those files are aware that they're meant to be separate entities, and when you squash them all together, you may have to rewrite some of the module syntax so that they appear to be a single module. So then what happens when you want to add, let's say you want to start writing your code in TypeScript instead. So the natural thing, the evolution was, so each of those three tools has plugins. And so for each of the popular bundlers, for each of the languages, somebody says, oh, I can become mildly famous on GitHub, so I can write this plugin for this thing. So that now and for some languages, like TypeScript, there are several different plugins to choose from. And so that just plugs into the bundler, and so when it's doing its job, it just runs this extra step along the way. And of course, this is accidentally becoming a build system. But it doesn't have the properties that you're familiar with in Bazel. For example, the plugins are basically, the plugin API is not that sophisticated, and so plugins can interact with each other in weird ways, and you run the CSS one first, and then you run the one that's supposed to produce the app shell, and it turns out you're supposed to do them in the other order, and then they step on each other, and so this is really tough. And this is basically the way that Angular development is done today. So what we think we could do better. The build tool, as I think I've argued, is really core to being able to do these hard things, to deliver the kind of user experiences that we want from web apps. And so since most of you are not web developers, one takeaway I'd like you to have is that this, please don't just turn away and say JavaScript looks gross. The front end people in my company are doing something, and it's not the same thing I would do, but I don't want to get involved, because then I'll be involved. So I'm hoping that you'll get involved. And that having your front-end team use Bazel is a great way to start, start bringing them into all of the practices that you do. So I'm going to spend some time just sort of what are some of the building blocks? Basically, introduce the rule sets that are involved. This is pretty Bazel specific. Hopefully, it's interesting. A little bit of design, because we've just finished a redesign of this, which I'm kind of happy about. So rules Node.js. So does everybody know what Node is? This is a way to run JavaScript on the server. But since all of the build tooling in front end is written in JavaScript or TypeScript and transpiled to JavaScript, that means that we need to run JavaScript in the build system. So Node.js is the runtime that allows us to do that. So I'm going to talk about a few different ways to wire this up. The one I think for this audience that makes the most sense is you've installed Bazel on your machine already. But you work maybe across the full stack, and you don't want to have to go through a long README and get your computer in a special state where it can build the front end also. So of course, the whole tool chain should come down through Bazel. So I made a very short example here that's actually almost identical to what you will do if you take the boot camp this afternoon or tomorrow, which is just starting from Bazel. I just need to fetch the TypeScript toolchain. And I'll sort of show this over the next few slides. You don't need to read all of this. This is obviously a chunk of workspace file. We've tried to make this pretty short. So in this case, you're getting both the runtime and the TypeScript compiler because I didn't feel like picking it apart. So you just download your HTTP archive, and then the rest of it is calling some star lark functions. I have to remember to say it that way. If I say sky, think star. I assume that's going to be a common thing today. Right. So one of those steps, I don't know if it's that useful to point out, but one of the steps here was to call a helper that sets up the external repository called Node.js. So this gives you just the runtime and also the package managers. So you get these labels that you can run. So this Node.js yarn is one package manager that we think is the best for downloading stuff. It turns out the other package manager, npm, is better for uploading stuff. In the front-end ecosystem, there's a lot of yeah, it's pretty diverse. Sorry, we're supposed to use diverse for a more important purpose today. You can also just run the package manager. So this second line is would let you do like Bazel run the package manager. So that's important to add new dependencies, and then you can access the node runtime. Users typically wouldn't access these. This is just part of the toolchain. So, and I use the word toolchain. We're not actually using Bazel's toolchain support. This is just a regular repository rule that just downloads HTTP archive based on your platform. There may still needs to be some work there. So now that we have the runtime, we need to fetch all of your dependencies, like leftpad. So it's published again, so you can do that again. So there's this directory structure, which is always called node_modules. And the directory structure has to be in your project in order for most of the existing web tooling to work. And the runtime, the Node.js runtime, when you load a module, it actually looks at where it's being loaded from, and based on where it's loaded from, it will give you the right version of that dependency for that load location, which means you could have two different versions of the same library present, and when one guy loads it, he gets the one he needs, and then when this one loads it, he gets the one that one needs. So that's kind of complicated. We can't actually model that with workspace rules in Bazel because they all have to have unique names. So our solution, and also the layout of this directory is very particular. It's not worth trying to reproduce those semantics. So what we do is we run the native package manager. npm or yarn are both options. And then we're going to need a build rule so that when the build runs, Bazel knows how to go find those files. So that's the next step. There are a couple of options. One is that the user can manage the dependencies themselves. And this is where we started, because this is most typical to what web developers do today. So they would run the package manager themselves. The special directory gets laid out in their workspace. They use a .git ignore and tell their editor to ignore it, and then usual problems. And then you could use just a file group rule in Bazel to grab up all the whole folder structure. And typically, the label you would use is // node modules, which is the default in some of the later rules. We'll look for that. So the advantage of doing it this way is that all of the existing tooling is looking for this special directory. So for example, your editor wants to show you red squigglies in your TypeScript code. It needs to know which version of TypeScript you're using because the red squigglies change a little bit over time. And so it looks in this location for it. But of course, having the developer manage this file group is a nightmare because spaces aren't legal in labels. I think they may be becoming legal, but like Unicode characters are still not. And so if you download packages from npm, you'll find all of this crazy stuff that you can't even make a label in Bazel to reference these files. So the second option is to use the yarn install rule. And so the name npm here is going to be the name of the repository that this creates. And then we handed this package.json file, which is just the typical representation of what all of your dependencies are. And then there's also this lock file that comes with yarn, which pins your transitive dependencies, so we can try to make things hermetic. And then using this rule, the yarn install rule, Bazel will manage the dependencies for you. So now it will install into the directory. I don't know how many of you work on rule sets, but you get really good at typing Bazel info output base/external because you need that all the time. And what you get from the yarn install rule is fine-grained dependencies. So this is really cool. Paul Johnson here actually worked on a different set of rules for Node.js. And because, as Melody said earlier, we have this awesome open source ecosystem developing around Bazel, I went and looked at what he did and said, oh my gosh, that's way better. What we really want is instead of a giant file group, we want lots of small file groups so that we can have a smaller number of action inputs so that when we start doing remote build execution, we don't have to upload the entire node modules directory to every one of our actions, even though the vast majority of those dependencies aren't needed there. So what happens is during the repository rule execution, right after we call the package manager to install the packages, we generate a bunch of build files. We follow the dependency graph that the package manager had laid out, and we just mirror it into build files that have the right dependencies on each other. And then it also creates binary targets for anything that's labeled in that package as being executable. So this does have the downside that users have to put dependencies into their build files. So I'll mention TS autodeps later, which is one solution for this. We all want build file generation to happen. And then you can opt out of this fine-grained thing. You can use a catch-all target to just give you the old behavior of everything. So now it's faster action setup, scalable, and your dependencies are always up to date. You don't have to remember to run the package manager first. So like I said, you get @npm, and it has the package. It has a binary label you can use, and it has the catch-all target that gives you everything. So just some examples of how it would look to use it. So if you wanted to install the TypeScript support, you could do Bazel run. And then we're going to run the package manager, which is yarn. And we're going to tell it the command is add. And then we tell it to add TypeScript and @Bazel/TypeScript, which I'll talk about. This is the JavaScript code needed to run the compilation under Bazel. And then we can run the TypeScript compiler, the vanilla upstream one, just by referencing it, npm TypeScript/bin:/tsc, which is the name of the program. Oh, I did say Starlark. Oh, I updated this slide. I'm so proud of myself. So I won't spend too much time on this. We tried a few ways. We actually rolled them all out to production of making JavaScript and Bazel files work together. So the problem was, number one, we tried putting Bazel files into the npm package that you fetch. And the problem there is that there's a bootstrap condition where you can't run Bazel because the workspace file does a load from a node modules directory that you don't have until you run the package manager, so you can't use Bazel to run the package manager. So that was no good. The attempt two was we tried putting the JavaScript files or TypeScript files into the Starlark package. But now they don't live inside of that node modules directory anymore. And so if the rules TypeScript depends on a certain version of protobuf.js, which it does for the worker communication with Bazel, and the users installed a different version of protobuf.js in their own dependencies, then we don't get our right version anymore. So the answer we've come up with is what we're calling idiomatic install, which is we just give up. We're going to have two packages. So the Starlark package is downloaded according to the idiom that Bazel has, and the JavaScript code is downloaded according to the idiom of npm. And then at runtime, we just have to check that the versions match because we weren't able to ship it as one package. So for example, Karma is a test runner that was developed by the Angular team. So if we have that npm package and we need to add some JavaScript code, typically run files is the reason we need this. Then we can make a package @Bazel/Karma. The @Bazel here is a scoped package on npm, which just means that we can put everything under this directory. And it also gives users an easy way to know if I use package X, then I might need @Bazel/X to go with it. We only have a few of these so far, but this seems like the pattern we want to follow. I'll briefly mention when I talk to the Angular developers, I don't tell them any of what I just told you because that's all scary for them. So what I tell them is, OK, you already have Node, npm, and yarn on your machine because you're a web developer. You're never going to install Bazel. I'm not going to tell you what Bazel is. And you can see this repo to see how this works. What we've done is published the Bazel binaries, just the bare exe and the binary files, to npm as dependencies. So you can make an npm dependency on @Bazel/Bazel, and now the Bazel tool just looks like one other process that your JavaScript build system knows how to spin up. And so we're trying to layer it in between. So I'm not going to talk about the rest of the rules. There's a bunch of things you can do. We do have our stardoc documentation site. That's here, and it's linked from bazel.build if you click on docs and go through to JavaScript. Rules TypeScript, I'll mostly skip over, but it does kind of illustrate this idea of you need JavaScript code, which is @Bazel/TypeScript, which goes along with the TypeScript package that's shipped by the team at Microsoft. And then separately, you have the HTTP archive to get the rules TypeScript where the Bazel code lives. And so this gives you the TS library rule. It's kind of a good example because it uses a lot of Bazel features. Actually, it uses the workers so that the compiler can stay running. It has providers to give you the different flavors of JavaScript. Like I said earlier, for custom elements, you want one flavor. For a bundler or an optimizer, you might need one flavor. For working with an older browser, you need a different flavor. It also illustrates the multi-language thing because the dev server here is written in Go for performance. And then also from the TypeScript layer, we are working on this tool that writes the build files for you. So internally at Google, we are already using this. The external version is called TS Autodeps. It doesn't work that much yet. It's kind of in a V0 right now. But the idea is that you could do Angular development and never look at build files. And again, there's the star documentation for the TypeScript rules. OK, so this talk was supposed to be about Angular. I have 5 minutes left, so I better talk about Angular. So we did write Angular rules. They run the Angular compiler. You can use them to package up libraries in the Angular ecosystem. There's a lot of front-end widgets, and you want to be able to just in fact, there are companies whose business model is to make widgets, make components, and sell them, and you can get a license to use their component in your app. So there are a few rules in here to give you the whole end-to-end experience. This is somewhat new. So my friends from Lucidchart have been using this. They're one of several companies rolling out using Bazel to build Angular. At Google, we've been doing this for a long time. Analytics, Shopping Express, Cloud Console. We have a number of pretty large apps. Sorry, I'm doing the slide backwards. And then we're dogfooding it. Angular itself is now using Bazel for build and test. And I'm still trying to get the team to remove some of the vestigial bits from the old build system. Build system migrations are hard. They're hard to prioritize. We could do. I hope there's a talk about that. Just the emotional support you need to keep going. So of course, Dave gave this awesome talk, which you should watch if you haven't, sort of introducing to the world the remote build execution service that the Google Cloud runs. And so the next question is, well, we said that good rule sets should be remote execution capable. So we do have that. And so when we turned on the remote execution, actually, it was Wei from the RBE team who helped us set this up, so thank you very much. This is in seconds. Sorry, I didn't label the axis. I know that's a way to lie with statistics. So it got faster. Blue bar smaller is good. And then when we went from the coarse-grained dependency on the olive node modules, and we're uploading the whole node modules to every action, to the fine-grained one, where we only have the individual packages that we need, got a little bit faster. I think that didn't make a big difference because of the caching that the remote build execution has. But probably reduce the sizes of the uploads. So, oh, sorry, I was going to show you in the 3 minutes I have left a quick demo. So while I'm waiting for my machine to come out of Hibernate, I'll tell you a story, which is that I'm using Windows, even though I work at Google, because I'm different, and because I had to make all of this stuff work on Windows. So the cool thing is I'm going to do a demo on Windows. OK, this is Windows. I don't know how I prove that. What do I type? Does anybody know Windows? Do I type like uname? Oh, OK, that worked. So this demo is not going to show you Bazel at all. This is actually what Angular developers would like to see, which is they all run a tool called ng. And this is the Angular CLI. This is distributed as an NPM package, and it's installed globally on your machine, which is another fishy practice we have in front end, where just the ng command is some version of Angular CLI. And then it has some commands, and I'm going to do serve. And then it can do a production mode build, which is going to run extra build steps to make the thing extra small. And then let's see how the demos are going today. So this isn't going to show much output. And in fact, we might want to use the build event protocol to show even less of what Bazel is doing. So there's a target source/prod server. The Bazel RC file change is confusing to me, but hopefully that'll be finished before 1.0. OK, so there's some Bazel output that's familiar. So it built something, and now we're running this production server. And so it does some of these cool things that Angular developers would expect. I don't know how interesting this is for everybody, so I'll breeze through it. But the important bit is that when I go to the network tab and load this app, I downloaded a bunch of these chunks. I should learn how to use this better. It should use iBazel. So let me answer that in 1 minute. So now when I click, let me scroll down over here. So when I click this to-dos, I just fetched another chunk. So this is doing the lazy loading thing. And then, yeah, I could make a change in the source code, and it would turn around pretty quickly. Yeah, I'll just answer the iBazel really quick because I have enough time. So we can switch back to slides. So Bazel by default doesn't have a watch mode. which it's been a feature request for a long time internally at Google also. So my coworker who actually led the effort to get TypeScript as a language at Google also wrote this thing iBlaze, or iBazel, which is actually very simple. It just does a Bazel query to find out which, although we don't do that part anymore internally because we have a different file system. But you imagine it does a query. It finds out what files in your app might affect the targets that you've asked to run, build, or test. And then whenever those files change, it just redoes the run, build, or test. So simple. You just have it's a pretty short Go program, and it gives you a watch mode for Bazel. So yeah, most web developers expect watch mode in their tooling, and so iBazel is part of that. I didn't do that in this demo because iBazel doesn't work on Windows, along with a few other things. So that's something to fix. Right. So tomorrow there's going to be at 5 o'clock. You can talk JavaScript generally. It doesn't have to be about Angular. We support other web frameworks too. And this is my short link for all of the things related to converging the build tooling and using Bazel under Angular. So I linked to the slides off of there already. So that's it. I do remember we had an issue filed on one of the repos for something to do with native, and I'm not sure what it was. But in theory, yes, we should support whatever your front-end development is now. It should still work under Bazel. OK, thank you.